Hey everybody, going to stream in a few seconds, just getting myself extra ready. Extra ready. Walking around my house, going to different rooms. Get my other battery. Close the door. Hello everybody, welcome again to Comp 1720/6720. This is your weekly code lecture for week 3. It is 2:05 p.m. on Wednesday, August 12. That means it's time to start and get into it. Thank you so much for joining me. If you're listening live, I know there's a few people out there listening. I'm here on Teams to answer any questions you might have. Shuai's just asked me, do we start now? We do start now. We do. I'll type in, we do. Yes, you know, I just start lectures when I think that there's a few people here. People tend to show up over the next 10 minutes if they're going to be watching live, so it's a good time to start right now. Today I've got another lecture for you when we will be doing looking at two really important pieces of code theory, two really fundamental things in computer science. One is conditionals and the other one is iteration, the flow, controlling the flow. through different ways. Both of these things will let you control the flow of your programs. So it should be a fun lecture. I'm going to try to, write some live code as we go, but to start with, we'll just get through a few theory slides and a few admin ideas and then get right into it. So, a little synopsis of last week's lecture. We'll start with that actually. Right after our admin time. Admin time, I need like a little admin time jingle. I guess I should say I had new music today. The music from the previous 2 weeks was something that is open licensed on the internet. It's under a Creative Commons license, so I was able to use that in our lectures, but I'd really prefer to use music from musicians that I know. And actually there are lots of great musicians at ANU. I'm sure there are great musicians out there in the class. Maybe one is you. And I played back a piece which is written by T. La, or Thomas La, who was a former student of Comp 1720. I'm not sure when he took Comp 1720. It might have been last year, but it's great that T. La gave me that piece so I could use it for my intro video. Now, here's the admin stuff of the day. The most important thing that I want everybody to be thinking about is, have you started assignment 1? Do you know how to get assignment 1 organized, submitted, written, and pushed up and fully completed by Monday evening? Monday evening is the assignment's due at 9 p.m. on Monday evening. I'm going to do a little bit more of a talk on the assignment right at the end. I'm even going to show you an example assignment submission so you can really see what we're expecting. I think many of you have looked at it and realized that assignment 1 is not too hard. We're really asking you just to make a static image, write a little bit about what you've done, and start to practice your creativity and your coding with p5.js. What many people find is that the more difficult part is actually making sure you have your head around GitLab, Git, VS Code, and how to submit things for this course. So you've already had a few practice goes at that. You've probably submitted your Circle on the Internet from week 1. You've probably submitted your Pledge of Integrity from week 2. You've probably submitted some code this week on GitLab from your week 3 lab exercises. But still, I know some people will be a little bit shaky about Git, so make sure you get on top of it early. You can commit your assignment to Git as many times as you like, and whatever you submit, the latest version will be what we look at as of 9 p.m. on Monday. But the most important thing is that if your assignment is not submitted on Git, then we can't mark it. So make sure it's submitted, make sure you get something started. If you haven't forked your assignment repository yet on GitLab, you will find that I sent you an email about that this morning suggesting that you please fork it soon, if not right now, so that you know what you're doing. Tomorrow I'll be sending an email to everyone who has forked the assignment but not committed the assignment to make sure that you understand how everything is working and you've made a first commit. I really just want people to make a start so that they've practiced this GitLab pushing procedure really before the weekend, because on the weekend we can't help you with your assignments. We will have an assignment help session on Monday afternoon after the labs, which I think means it'll have to be 5 o'clock. I'll just check that. But the assignment help session will just be an hour and will only be related to help with Git, not help with the content of the assignment. So we just need to make sure that everyone who can't work out how to get their assignment submitted can do it. So please remember to complete your Pledge of Integrity as well if you haven't done that. It's another good practice in using Git, and also it means that you've got an agreement with us to keep up the standards we expect at ANU in your work, and that we will in return mark your code. Remember that if you need help with Git, we have some videos on the website which I've been pointing people to. Hopefully they're helping. If you have a problem that's not in the videos, we'll also help you on Discourse as a first entry point. But really the main admin point of the day is to start your assignment, please. Please start it. Please, guys, folks, make sure that you're getting started with things, and otherwise we just get driven mental on Monday when everyone is panicking about it. That's it for admins for the day. Well done in Lab 3 this week. I know that those are all finished now. Another bit of news, which is really, really important and exciting, is that we have 2 course reps for the course. That's Jarvis Wang and Benedict Cusack. Welcome, Jarvis and Benedict. I know Benedict is always watching. He's a dedicated stream watcher. Now, both of these people are here to listen to your concerns and issues. They're really dedicated to helping or being there in case people have problems in this course, and being a great kind of interface between the general feeling of the students, all 160 of you, and what I know about the course and what the other tutors and academics know about this course. So if you have any issues in the course, please, 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 please get in touch with the course reps if it's an issue that you feel you can't raise with me, and they will be able to pass it on to me anonymously, and we can do what we can to make things right. And now I've got 2 course reps, but these folks are fantastic, but they're both from Comp 6720. They're both graduate students. So I'm looking for a Comp 1720 person as well who might like to be a course rep. If you think that could be you, get in touch with me if you want to volunteer. All it means is attending a few meetings with the other course reps and being that person who someone can talk to if they have an issue that they feel they can't raise with me. And being a bit of a pressure relief valve can be really great as well. So it's wonderful when people volunteer to take on that responsibility, even though it's not too much work, but it's really important to have there. So that's all I'll say about course reps. I think Jarvis and Benedict will introduce themselves on Discourse to you soon. Yeah, Benedict has just jumped in the comments. Thanks, matey, that's great. Now, just a very quick overview of everything we've done so far in the course in code. Sometimes it's easy to forget what we did in previous lectures. So as a very basic start, P5 uses this kind of flow, right, of running multiple blocks of code. And you remember how blocks were set apart by the curly brackets that are around them. So P5 uses this setup, draw, 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 draw loop. And then we also have variables that are a way to give a name to a value. And the great thing about a variable is it's a named value which could change. There are some values like just 100 written down in your code, which will always be 100. It never changes. But a variable can be changed to something else. If you say var x equals 100, then x is 100 right now. But if later on we say x equals 115, x has now changed its value. So excellent to keep that in mind. We'll be using those a lot today. Now, this is something that we talked about last week, the flow. The flow is like a pass through your code as it gets read by the computer. So the web browser, the JavaScript engine in the web browser, is reading your sketch.js file and running through the code line by line. And we know that it runs through that setup block first, then it runs through the draw block. I've got one right here. Oops. Runs through this setup block first, then runs through this draw block, 1, 2, 3, and it does that over and over and over again through the draw block, 1, 2, 3, 1, 2, 3, 1, 2, 3. And you recall from last week that we decided that it was important which order the lines of code are, because as you're sort of painting on the wall, painting on the canvas of your P5.js sketch, then the order that you're painting objects will make a difference. If you paint something on a white background and then paint a line over the top, the line will be drawn on the top of that object and not the other way around. So the order matters and the flow through your code matters. And what we're going to get into today are ways to change this flow within the setup block and within the draw block. So it won't be that you just have many lines of code that have to be executed in one particular order. It could execute some, then go back. It could execute some only under some conditions, or it could have a loop where it's executing another little area of code over and over and over again, or maybe a set number of times, or doing it over and over again until something else happens. So we're changing this flow. And this is a crucial thing about computing, is that within a computer program, your flow can change. The order of these lines of code being executed might go back, it might go forward, it might jump around, but it's predictable. And something you need to develop as a programmer, as you're learning to code, is being able to look at a piece of code and say, oh, I now know which is the next line that's going to be executed because I can think through the logic of these lines of code. So you're able to predict where the flow will go, as is the computer. We did talk a little bit about types last week, mostly numbers so far, where numbers are the most important things, 42 or other numerics. Some variables like height, mouse Y, frame count. We talked a lot about frame count last week, which was fun with the little race. But there are other types. These will come back in later lectures. We're not going to do any more on types today. So today we're doing these two new concepts, conditionals and iteration. These are the two we're worrying about. So, what is a conditional? Sometimes I do exams with students, and we take some basic concepts from a course, an interview-style exam, and conditionals will be on the course, and I'll go into the exam and I'll ask the student, what is a conditional? And they'll say, oh, I've never really thought about that before. So that's sometimes a worry if a student says that, but it's a good thing to think about. What is a conditional, even if you know what it is? So here we have an image of this person. I'll just make this full screen so we can see the full image. Here's this young person in a forest, and they have before them a left path and a right path. They can only choose one path. How are they going to choose? So what a conditional is a way of letting us choose a path through code based on some kind of calculation. So we can do this in English, right? We can make a sentence in English language which represents this choice. For instance, something like, if I can run, I can make it to the tram stop in time. And maybe if I made it to the tram, I will turn left. If the sun is out, I will turn right. So you can make a sentence where you say, if something, some condition, then I will do an action. So the conditional is a construct within a sentence that lets us choose which way we're going to go. Here's another one. If I have a spare month, I'll read War and Peace. I'm sure there are people out there who have read War and Peace. I have not read War and Peace, so I guess I can say if I have a spare month, I'll read War and Peace, but you know, the longer you go along in life, the less spare months seem to present themselves. So it may be a few more months yet. I'll start assignment 1 when I've finished watching Netflix. I hope that there's not too many of you in that situation. I hope that you've got a good plan to start assignment 1 before watching Netflix, and maybe watching Netflix is your reward for starting assignment 1 rather than the other way around. Although I know that can happen sometimes too. So this conditional is a way of representing a choice in our computing system, in our programming. Whoa, whoops. It was a misspelling. I think I misspelled finished. I will go back in the slides and change it just for you, Julian. You noticed it. We're now going to talk about how we represent truth. So within each of these statements, I guess, there was a part of it which was a true or false part of the sentence. If I have a spare month is either true, I have a spare month, or false, I don't have a spare month. For me, it's always false. I never have a spare month. I don't know who has spare months these days. I run. If I am running, then that could be true. If I'm running right now, I'm running. So that's true. If I'm not running, it's false. I've finished watching Netflix. I guess that could be true or false at any time, right? You could be currently watching Netflix, but you've finished and you're about to do something else and it's true. Or you could be not watching Netflix and you finished some time ago and it's still true, right? So these parts of the sentence are all things that are true or false. And within computing, we have a way of a kind of number that represents whether something is true or false, and it's a Boolean number. So this gentleman illustrated here is George Boole, a mathematician who, as I said last week, worked a lot on building up theories of mathematics that only need two kinds of numbers, false and true. So normally in mathematics we've got many numbers, but in George Boole's algebra, you only needed two kinds of numbers, false and true. So we call these Boolean values because they can only have two values, false and true. Now, this is the Boolean type in JavaScript. So unlike a number, which can take any value, Boolean variables must be either true or false, that bit. They only have two values. So here's a couple of examples. Variable, the sky is blue, true. Variable, the sea is red, equals false. Now it just so happens that both of these values, my pen's never going to work. I always try and I'm always disappointed, aren't I? Oops. Is my pen, no, don't print. Is it going to work? No. I'll try refreshing the page. That sometimes seems to help. I don't really know why it would. I have to get Harrison onto this problem. He's the slides man. Oh, it's working now, okay. So it does just so happens that this variable is called the sky is blue, and then it just so happens that I've typed in equals true. But I could also make it equal to false. Now the computer doesn't know anything about the sky. It doesn't know anything about blue being blue. And it really isn't reading the name of this variable. This variable is just a name to it. It may as well be called Murgatroyd rather than the sky is blue. The computer doesn't care. So if you type variable and call it the sky is blue, then for a human, we look at that and think, well, that's got to be true. But the computer doesn't know that it ought to be true or not. So if I made that variable false, the computer would be quite happy with it, but perhaps a human reading my code later would be like, well, that's very strange that this person has a variable called the sky is blue, which happens to be false. Why would they do that? Anyway, it's just a thing about these variables. Their names aren't interpreted by the computer except as a label for something. So the sky is blue is true. That matches with our human experience, so it's probably a good value for that variable. The sea is red is false, unless someone has a big accident with paint. But in general, the sea is not red. Now, you can actually do some maths with Boolean values as well. There's certain kinds of mathematical operations within all programming languages, they're very, very common, that return or have a result which is a Boolean number. So if I use this less than symbol, and if I type in something like 9 less than 10, then the answer to that statement is true. 9 is less than 10, absolutely true. I have many others, less than or equal to, less than or equal to. So 9 less than or equal to 10 is true. The same thing, because 9 is less than 10. Is 10 less than or equal to 10? Well, I said less than or equal to. 10 is equal to 10, so yes, 10 is less than or equal to 10. Okay, you get the picture with these Boolean logical expressions. These are really, really important. We'll get to these in a minute, but the other matching ones for greater than is greater than by itself and greater than or equal to. So is 9 greater than 10? The answer to that would be false, so that would give you false back. Is 9 greater than or equal to 10? Absolutely not. 9 is not greater than 10, and it is not equal to 10, so that's false as well. We've got this funny one here, which this one can trip up people who are just starting with programming for the first time, that there's two equal signs together. And that is testing whether something is equal to another thing. So is 9 equal to 10? No, it's not. If I put 9 equals 10, that would be calculate to false. But if I had 10 equals 10, it would calculate to true. And then kind of the opposite of being equal to is being not equal to. And a lot of times in computing, we use the exclamation mark to mean not. It's a bit strange to use that for not, but after a few, a few weeks or months or years, you might get used to it. Exclamation mark followed by an equal sign means not equal to. So 9 not equal to 10 would resolve to true because 9 is not equal to 10. So far, so good. We've got these Boolean logical expressions. You can have a look at these in the MDN docs, but I think it's better when we look at a few examples for a minute just to get the hang of how these things work. So here's a few Boolean logic expressions. Variable x is small is when mouse x less than 100. So when mouse x is less than 100, this evaluates to true, and that means, I guess, that the x value of the mouse is small, right? 100 is pretty small. It's only a little bit in from the left side of the window, and so that would evaluate to true when the mouse is in that close to the left side of the window location. Y is big, when mouse y greater than or equal to 500. So we've got greater than or equal to now. That means this is going to evaluate to true as the mouse gets to 500 down from the top of the screen, or greater than that. And then a final one, var Jan is happy equals not true. Some of the Australians in the audience may recall not happy Jan as a bit of a meme like 10 years ago or more, 15 years ago. So that's probably one from the deep past, which we could probably forget. You can also combine Boolean expressions together, and I'll show you more examples of this later, but we can use these logical operators to combine a couple of conditions together to make something more complicated. So the two that are important, we've already sort of seen not, and we've used that. You can use that as an operator. It's an operator which only takes one value. So not, the exclamation mark in front of whatever it is, swaps around the truth value. So if whatever the expression is evaluates to true, then not that will be false. And if whatever you put that in front of is false, it'll be true. Then these other two, and or, they do what they say on the tin, right? They do what they're named for. The and operator means that the whole expression will be true if both things on both sides are true. And the or operator means the whole expression will be true if either side of the or operation is true. Just like greater than or equal to. That is true if the expression is greater than or if the expression is equal to. So here's a few that are important. A few expressions with these operators. So the sky is blue and the sea is red. Now we know that the sky is blue is true and the sea is red is not true. So that means that this side is true, but this side is false. So true and false is not true, that's false. The sky is blue or the sea is red. That's true. This is false from before. But because one side is true, the or expression is true. So the whole thing is true. Then not the sky is blue. Well, the sky is blue is true, so not the sky is blue is false. Well, it can be a bit of brain work to work through these things, but it's something you need to practice, and it's really important in your code for defining the flow. So here we go. Here's an example of something. I'm just going to copy this into my code right now. I didn't make this one, by the way. It's built by the previous lecturer of this course and a friend of mine. And I think he was singing a song about love or something, so he made this example for talking about conditionals. So here is unconditional love. So we haven't got any Boolean values in here right now. We're just drawing a nice heart on the screen. Why are we drawing a nice heart on the screen? Because it represents love, and we're doing it all the time. So there's no way to make this heart go away within this program. It's running right now. We're just going through the draw loop over and over and over again, down from the top, and we're always drawing this heart. But what I want to do now is make this so that love is not unconditional. I want to make some conditional love right now. So supposing, this will be unfair, you might say to your significant other or boyfriend or girlfriend, Well, I only love you when mouse X is greater than 100. So how am I going to do that? I've kind of also got this thing here. We haven't really talked about this, but this is the conditional statement, if. So I was going to draw a love heart if mouse X is greater than 100. So mouse X is a variable. I can type that in here. If mouse X is greater than 100, then I want to do the following, all these lines of code. So how do I tell P5 to do all of these lines of code kind of in a chunk? Well, I can use the curly brackets, which give you a block of code. We use those for the draw loop, that gives you this block. And now I want a block of code that executes only if mouse X is greater than 100. Now, because, you know, I guess I'm a programmer for many years now, I've got to get my indentation right, otherwise I get sad. So I've got to make sure that I can see all my nicely indented code there. Ooh, it makes me feel good to see all of that. So perfect, 2 spaces in from the if statement. Okay, shall I run this? Oh, I might want to put the background outside of that loop. That's not going to, well, otherwise it won't. The background always runs, and then the heart only runs if mouse X greater than 100. Let's try that. Okay, mouse X is somewhere. Oh, there's my heart. Now it goes away. Conditional love. Conditional on whether mouse X is greater than 100. So what have I just done? Let's have a look at it again. I've figured out what the Boolean expression is for my condition, right? If I run, I'll make the train. If I finish watching Netflix, I'll start the assignment. If mouse X is greater than 100, I will draw a heart. So I've decided that mouse X greater than 100 is this Boolean expression, and I've expressed that in code. So mouse X is a variable representing this number of where the mouse comes in from the side of the screen. 100 is a value, it's always 100, it doesn't change. And then the greater than sign is a Boolean operator, which will return, or it returns a Boolean value. It's not a Boolean operator. It returns a Boolean value when the thing on the left is greater than the thing on the right. So mouse X greater than 100 is my Boolean expression. That is true if my mouse goes outside of that. So far, so good. Then I've got this conditional expression with if to complete the sentence. If mouse X greater than 100, and I put my Boolean expression inside regular parentheses here, that means it's my condition, then I run this block of code. And if itself doesn't really know what the block of code is, it just knows that it ought to be followed by a block of code. So if mouse X greater than 100, do all this. Draw a heart. Conditional love. Not unconditional anymore. What about something else? Conditional love only if I'm clicking down the, oh no, I didn't want that. I want mouse pressed. I'm clicking on the mouse button. Mouse pressed. So now I'll get the love heart will be drawn only if I click down. Whoops, I need to reload. No, I thought this was going to work. Mouse pressed. Is pressed. And now I'm confused about, oh, here it works. There we go. Click down, mouse is pressed, and I get my love heart. I got a bit confused about P5.js, or maybe I'm not, and I'm just psyching myself out for a minute. Mouse is pressed. That's conditional. It's a Boolean variable, which happens to be true when I'm holding down my mouse button. Maybe I'll make this animated a little bit nicely with my fade out trick that we tried last time. Oh, there we go. It's like a beating heart, so you can animate it with our mouse. What about a more complicated condition? I want the love heart to appear when mouse X is greater than 200 and, ooh, I don't know. And I've got a funny keyboard here on my desk, and I sometimes forget which buttons to press to get certain symbols. And mouse Y is less than 300. So now we've got two conditions, and we're using an AND to put them together. So mouse X has to be greater than 200, and mouse Y has to be greater than 300. So Y has to be close to the top of the screen. Let's see how that goes. So if I'm too close to the X to the left side of the screen, it disappears. I'm using something. I'll show you my keyboard in a minute. My mouse goes too far close to the left, it disappears. And if my mouse goes too low down past 300, the heart disappears as well. So we can get a more complicated Boolean expression. Can I add more things? I certainly can. I need to be inside that parentheses, and mouse is pressed. So now it doesn't do anything until I'm in that location and I press the mouse button. But if I'm out here and I press the mouse button, no heart. Sad. Okay, so now we've looked at a few different kinds of conditionals and perhaps made a complicated Boolean expression. Let's keep moving through these concepts. We've got iteration to work on next. Yes, I did the if statement. We worked on that. Yes, if condition do something. Oh, I forgot else. Sometimes you might want to do one thing if the condition is true, and then you also want to check if it's not true and do something completely different. So you can have the else follow the if by an else right there, right after it, and then have a second block that runs only if you don't want to do, if this condition is not met. So of course, a Boolean condition is either true or false. So if it's true, we do this, and if it's not true, we do that one. You'll try it in your labs. I hope everyone is practicing this stuff. We did that. Yes, now if you want to learn more about Booleans, I suppose you could take a philosophy course on Boolean logic. This Boolean type is built into JavaScript. It's a special place for storing true or false values. If you want to learn more about love, I'm not sure that this is the course for you. We're probably not going to talk more about love until the end of the course, but you could take Psych 1003. Perhaps you would learn about love in the brain. I'm not sure what else to recommend if you feel you need to learn more about unconditional love. There's a few examples of what Boolean variables could be used for here. I think we tried a few in that little demo right then. Has something been clicked? That was what I was doing with the mouse. You could also check if something is finished. You could be checking time using frame count. And you could also be storing some of these values, a complicated Boolean value, into one variable that sort of keeps track of the state of your sketch, the state of your artwork. This will be much more useful when you're doing artworks that are dynamic or moving or animated or interactive after assignment 1. There's a bit of a note here that there's some things we talk about in this course which are really P5 things, like mouse is pressed, that's P5. Mouse X, mouse Y, all P5. But the if statements and the loops we're going to do in a minute are JavaScript things. So you have to look in the Mozilla Developer Network docs, like this web page, to see how to use those things. And if you want to look up a P5 thing, you look in the p5.js reference. So it's a bit complicated that there's two different references, but in the lectures it's pointed out which one is most appropriate. Now we got there, iteration and loops. So I guess in our previous examples, we were able to break the flow in a predictable way. So we were able to choose when we were running these lines of code and when we were not running them as we're going through the draw loop over and over again. Now we can choose to do iteration, which means we take a block of code and we run it multiple times under our control, predictably. How do we control whether blocks of code happen multiple times or get run or change in some way? We use conditionals. We use Boolean expressions to control whether some block of code is going to be run multiple times. So you've already seen one loop, right? The draw loop, but now we get to be in control of this. So here's one type of loop. There's two types of loop we'll talk about today. This one's a very simple loop, but very important, very widely used. It's called the while loop. And we say while, this important word here, then a Boolean expression in parentheses, just as with the if statement, while condition is true, do the things inside the brackets. Do some things while condition evaluates to true. So this is handy. You may not be able to think of a way to use this first of all, but we'll look at an example in a minute. But just take a minute to think about whether this looks familiar or not, okay? Here's a human language intuition. We've got some kind of Boolean situation. Agatha is sitting, that's a Boolean variable. So we could have while Agatha is sitting, draw circles on slide, and maybe that's a function. Draw circles on the slide. So somehow there would be a sensor that works out whether Agatha is sitting or not, and while she is sitting down, the circles are being drawn on the slide, and when she is not sitting down, there's no circles being drawn. While triangles have three sides, draw circles on the slide. Now this is a tricky one. A question I would ask you is, will this loop ever stop? That is, will we ever exit the loop? Will this statement here ever be not true? I suppose Agatha could always be sitting down, but if she gets up even for a second, we will exit the loop and go somewhere else. Go into code below this block of code. And usually we consider that good. It's usually considered good to be able to exit a loop. In this second example, while triangles have three sides, will this ever be not true? Now I told you before, the computer doesn't care what Boolean value is in that variable, but we as humans kind of assume that that would always be true. Triangles do always have three sides, that's kind of the definition of a triangle. So it will always be true, that means we will always draw circles, and we will never get to the end of the loop, the end of this bracket block, and run code below it. And that's usually considered to be bad in computing. I guess we do have one infinite loop. This is called an infinite loop if it runs over and over and over again and never exits the loop, never stops. In our processing sketches, the draw function is kind of an infinite loop. It runs over and over and over again and never stops. The setup function is not an infinite loop, it just runs once. So here's a working example. I'm just going to copy this in somewhere. Working example. Whoops. It's working in some way. I've kind of forgotten what it does though. Let's work through it. We'll just think through the problem before running it. We've got a variable called count, which starts at 0. So while count less than 5, that's a Boolean expression, it will have a true-false answer. While that's equal 5, we draw an ellipse with random location in the screen, and then we're going to use the count variable to generate its width and height. That will be its width, will be 10 times count, width, and then height will be 10 times count as well. That's going to be x. Just putting in a few comments so we can see what's going on. That's going to be y, random height, random width. Width is the width of your browser window, or the width of the canvas, and height will be the height of the canvas. And then after we draw that ellipse, we take count and we add 1 to it. So count equals count plus 1. There's some good good Boolean expression examples going on in the comments right now. So we're incrementing this count value. Now will this loop ever exit? Let's have a think. We start with count equals 0. We check if count is less than 5. It's true. That's okay. We're going to run the loop then. We draw the ellipse. We add 1 to count. So count is now equal to 1. All right. Check if 1 is less than 5. Still true. Do the ellipse, count equals 2. Check, count less than 5. Yes, true. Draw the ellipse, count equals 3. So on, count equals 4, so on. Count equals 5. Now we check count less than 5. Is 5 less than 5? No, 5 is the same as 5. 5 is equal to 5, not less than 5. So that means we don't run this code in this block, and we go to the end of the draw function. Now if I run this, it's going to be, things will be a bit wacky. I don't actually want to run it there. I'm going to run it in my setup, I will run it in my setup code. Sorry about my syllables there, we're getting all stuck together. I'm going to run it once and I get 4 circles. I guess that's kind of because my width and height is being multiplied by count. If they're being multiplied by 0, I might change that to 1 and change this one to 1. Now I get 5 circles, 1, 2, 3, 4, 5, of increasing bigness at a random location. So that's my while loop. Now this kind of harkens back to something that Tony was saying a few weeks ago, which I thought was really important. And it's an important point about the value of doing art with computers. So what Tony said was, now you know how to draw a circle on your computer. You can use ellipse. That means you know how to draw 2 circles, because you can take ellipse and then you can copy and paste another ellipse below that and change the numbers. You've got 2 circles. Now, if you wanted to draw 10 or 20 circles that way, I suppose you could keep copying and pasting ellipses all the way down your code. And maybe that's what some of you are doing in your name tag, which is no problem with that. I guess there's no problem with that if you're doing 10 or 20 circles. But say you want to do 100 circles or 1,000 circles, right? Then it's going to start to get annoying to have to copy and paste that circle all the way down your page. In fact, I think it's probably too annoying to do to copy and paste in 1,000 ellipse bits of code. And if you did that, actually, your sketch would start to slow down. It wouldn't work very well. Or it might be slow to edit it. It would work fine, actually, with 1,000 of those. But it would be slow to edit. You would lose things. You wouldn't know what's going on, because there's 1,000 ellipses and you don't know where they're going. Now, if I change this to 10, rather than 5 circles, I will get 10. That will get bigger and bigger. If I change it to 20, I get 20 circles. I gotta get rid of no strokes so that I get little backgrounds on them. If I change it to 100, I get 100 circles and they end up really big. I might change this to, so that they're smaller. I might get them even smaller than that. If I want 500 circles, that's easy. Okay, so I can make as many circles as I like with one little chunk of code. And so the length of my program is not kind of constrained by the amount of stuff I want to do. I can do really complicated stuff with a very short program with iteration. That's why you want to use iteration in your code. That's what makes making art with computers really, really exciting and fun. You can have a simple idea and then extend it in a complex direction by using the power of coding, these different conditionals and iterations to do it. There's stuff going on about tea time in my chat. I'm not sure if you folks understand the point of chat is to ask me interesting questions about the lecture, but that's fine. You can have tea time in the chat as well. We'll go back to the slides. I've got a few more. Oh, here's a cool one. This is a cool example. Another while example. I'll just, whoops, uh-oh. I don't want to lose my place. Oh, I keep losing my place because I lose my key combinations. Okay, this takes up the whole screen. What's going to happen here? We've got a setup function. We've got one while loop. That's the centerpiece of this little sketch. We've got a setup function where we're creating our canvas. We've got no stroke. That means we're not drawing the outside stroke on the edge of shapes. We're just doing the fill. And we've actually changed the frame rate to be slow, just 5 frames per second. That's handy. Then we're going to fill up the screen with some shapes. We're going to draw a bunch of shapes across the screen that will be basically filling in the screen from left to right. So you can see we've got some variable x, which we're setting up to be 0. And then we're drawing a rectangle starting from x and y equals 0 for a random amount at a random height, a random percentage of the height of the screen. And then we're adding another random value to x to push it along. So we're doing this over and over again until we fill it up. So how many times will this loop run? Is there a way to find out how many times that loop will run? Well, in the previous example, I could figure out that it was going to run 5 times because x would start, the value I was looking at would start at 0 and then go 0, 1, 2, 3, 4, and then when it hits 5, we stop the loop. With this one, x is going to happen multiple times. First of all, to the width of the window, which I don't even know how many pixels that is. Second of all, we are adding a random amount of pixels each time, so I don't know how many times it will take to get to the edge of the window. So I don't know how many times while it's going to run. But do I think that it will ever stop? I guess it might stop. It might never stop if x is stuck less than the width of the window. And Benedict has just suggested maybe I could estimate it. I guess I could. We could work out some estimations with some maths, but just intuitively, it's very unlikely that this random 10, which returns a number between 0 and 9, will return 0 all the time. It can return 0, but it's not always going to do it. I think it can return 0, I hope. Random. Whoops. Random. Yeah, it takes a number from 0 up to 1, no. From 0 up to that number. So it returns a number between 0 and 9. Just as I suspected. Well, let's see what it looks like. So it's probably going to finish the loop in each iteration of the draw function. It'll finish this while loop, but we just don't know how many times it's going to take. And every time we run it, the pattern will be different. And the fill colors we're using will be different as well. So this is pretty cool. Kind of a nice sketch, right? Yeah, I think Benedict is right with that estimation. You can work out, I guess, you can end up working out the average amount, something like the average amount of bars you will get in the screen of iterations through this while loop. But you'll never know exactly what it is in any one program run. So it's semi-predictable, right? So this is a cool thing, making while loops that run a random amount of times. That's really exciting in computing. That means it's a little bit unpredictable. Ooh, would look nice with a fading background. I'm going to make that fading background. Thought no one would ever ask. 30, 30. I'm going to make it like, this is only 5 frames per second. Oh yeah. It looks like one of those old Winamp visualizers. If anyone knows what Winamp is and knows what a visualizer is, then that would be cool. Yeah, anyway, I'll let you play with that one. It's in the slides, there for you to play with. Let's keep going. I was somewhere in the middle here, wasn't I? 26 maybe, 23, 4, 5, 6-ish. Okay, that was my second example. Looping tips. So, some big looping tips. I did say that loops that loop forever are usually considered to be bad loops, because we never get to the end of our code. So you need to make sure that your Boolean expression will evaluate to false at some point. Otherwise, you'll never be sure of what, you'll never continue in your code, and you can find that your code will actually stop and you won't be able to get it to change, or your sketch in the browser. So you probably want to have some variable which you're modifying in your loop, and then when these modifications are done, the expression in the while loop condition should be false. So that's how we escape loops, by somehow having an expression evaluate to false. Whoop. A second kind of loop, and this is one that's a little bit trickier. I mean, it does the same thing. It's going to loop a block of code, but it just provides a little bit more machinery to do loops in a certain way. So this is a kind of loop which is often used for when you want to count from one number to a higher number and then do some code for each of those numbers in the middle. Just like we did with the count equals 0, count plus 1, count equals count plus 1 example just before. So this one includes a definite place to define a counting variable. So we use for variable I equals 0 until variable I is while variable I is less than 10, add 1 each time. So it's got this modifying the loop variable bit built in, it's got defining the variable built in, and then it's got a place in the middle for our Boolean expression, I less than 10. So what's going to happen in this loop? First of all, we'll run this bit of code, work out that we're in a loop, and to start with, I will be 0. That means I is definitely less than 10, so we run this. After we run it, we get to the end here, then the for loop automatically adds 1 to I, because we've put this in here, I equals I plus 1. Then we go back and do the same thing again. Check if I is less than 10, I is 2, 2 is less than 10, good. Run the code, then add 1 to I again. Okay, we keep doing that until we get I equals 9, I less than 10, 9 equals less than 10, yes, true. Run the code, add 1 to I, means we get 10, and that means when we get back here, it will check if 10 is less than 10, get false, not run the code in the loop, and move on. So it's a little bit more detailed. You can do the same thing with while loops, but if you do a lot of loops with a kind of counting variable that counts up or down, you can change this to I equals I minus 1. It could be I equals I times 2 or whatever. You can do whatever you want in this little statement. It's just some way of changing I each time. This is one way of just making your code a bit shorter. And it's useful because it is kind of self-explanatory what it's supposed to do. Whereas the while loop can, when you're reading it later, you can sometimes find you've done something a little bit weird and be confused about what you're actually trying to do in your loop. So for loops, they're great. What's the difference between while and for loops? What are the differences between these two loops? Are there any? I don't really think there are in this case. There's no obvious differences between these constructions. This is what I expect a for loop to be. So this one is the same as that one, or has the same behavior. And the only difference is that this one is a little bit shorter to type out, or maybe a little bit easier to understand. Yeah, so this is what we've done this week. We've worked on these Boolean expressions, e.g. mouse x less than 500, and the if statements. And we've looked at two different kinds of loops. I might do another demo of some loops in a minute, but I want to finish off the content of the lecture first. I've got a little demonstration to put. Yeah, that's right. So Benedict has suggested that one subtle difference here is that this variable I exists outside of that loop. In this case, the variable I exists inside the loop only. That's called variable scope, and we're going to talk about that in a later week. So that's a very subtle difference. Yep, very subtle. Diff on variable scope, but the variable is incremented after the loop code in both. Yeah, but I equals I plus 1. It's incremented here at the end. Even though it's written here at the start, it's incremented after that code runs. So it's incremented in the same spot. Okay. Yaya is asking me a question. When Yaya asks me a question, I know I'm in trouble. X not equal false and Y not same as false is the same as X is true or Y is true. Are you trying to like De Morgan's rule me into oblivion or something? I'll work on that one in a minute. Yeah. Let's talk about the assignment. So for the assignment, you have to submit 3 things, right? 3 main things. You got to submit your code. You've got to submit your PNG file, nametag.png, and you have to submit an artist statement. All of these things are necessary in order to get good marks for this assignment. You can't skip part just because it seems like it's a little bit tricky or difficult to do. You'll lose marks if you skip any of these parts of the assignment. So one bit which is a little bit, some people might feel a little bit tricky, is this artist statement bit. This is what you've been training for in doing your visual diary, okay? When you're doing your lab work, you're training to do the sketch.js, you're making programs, making art with code. When you're writing visual diaries and understanding works of art and writing about them, you're training to do an artist statement. That means you're training to describe your artwork and your process of creating something. So what do you have to do in an artist statement? The point of an artist statement is that it's short, 200 words maximum. Write it in the first person and you answer one question. What are you trying to achieve with your name tag as a work of art? So it's about you. That means you get to write in the first person. Not one created a name tag that had my name on it. It's your name tag. So write, I created this work of art by doing this. My inspiration was this. I wanted to communicate this. I wanted the viewer to feel this. So these are some questions which you could talk about. What's your inspiration? What are you trying to communicate? What are you trying to make the viewer feel? What concepts do you want to explore? And how are you balancing the idea of being able to read a name tag? It does have to have your name on it, with making an interesting artwork. So I've got a few slides about this. Here's an example of a really, really great name tag made by Kieran. Kieran is one of our PhD students here at the ANU, working with some of my colleagues. He used to be a tutor in this course. He'll be giving you a few lectures in this course later this semester. But his artwork is really interesting and striking colors, interesting font, interesting pattern here in the background. And so that's great, you know, there's a lot here. I can, just by looking at it visually, I can like this artwork. I think that this is interesting and artistic. It's definitely readable. I can see his name, very bold idea, very sort of clear design. But the artist statement can make it even better. So here's the artist statement. I'll just read it out. This is 188 words, so this is less than 200. This is the amount of text I expect you folks to write. Here's Kieran's artist statement. My name tag is inspired by one of the earliest examples of popular generative art, 10 print, chur, $205.5 plus rand 1, semicolon, colon, go to 10. It's a one-line program for Commodore 64 computers that would randomly pick between 2 characters, / and / to generate a maze on the screen. This program is an incredible example of the power of simple generative process to produce complex imagery. My sketch uses the same basic mechanism to produce the background of my name tag. Because the / and / look very different, I use P5 functions to create the classic shape for those characters. The blue color is inspired by the screen color of the C64, but I've brightened it for visual effect. For my name, I've chosen a font which has a similar computery style to match the background and aligned it with the rows and columns of the maze. I've used a red outline to contrast with the background to ensure that my name tag is easily readable and also to create a focal point for the image. So we know now what the inspiration is for this, and it's something cool, right? So that's great. It's inspired by something that makes me more interested in this. I know that he had to take a bit of a detour from his inspiration. He couldn't just use this Commodore 64 program. Kieran had to change this idea to make it work in P5 in the same way that it might have done on a Commodore 64 or in a similar way. Then he used a computery font for his name so that kind of ties the whole image together. And he's thought about everything in his image. He's thought about the colors to make sure that they're related to the Commodore 64. He's thought about the position of his name on the screen so it's matched up with the columns and rows. We'll go back to this. You can see it's matched in here, more or less. So this is a really well-considered piece of name tag art. And I think it's great inspiration. Why is it great inspiration? For me, it's inspirational because it's so simple. These are simple decisions, but of course, Kieran is a very good artist, and he does think about these things. So what I want to hopefully inspire you folks to do is to similarly consider every aspect of your name tag and do things which have, a level of consideration, a good inspiration, and explain all of those things in your artist statement. And the goal of your artist statement is that when I look at your artwork, I should say, cool. And then when I look at your artist statement, I should say, oh, actually, that's super cool, right? I want to be blown away by your artwork, or my experience of it should be enhanced by your artist statement. What did Kieran not do here? Is there any time in this when he has explained about the flow of his P5 sketch? No. Is there any bit of this where he has included P5.js code? No. He's explaining how he approached his artwork and what he did to create it. But he hasn't explained in detail about the code, things that I could have worked out from looking at the code itself. So that's something that you need to remember. The artist statement is not an explanation of your code. It's a piece of writing which enhances my understanding of what you're trying to do as an artist. So don't explain your code line by line. Do not do it. Think about the overall goals and effects you're trying to achieve. Talk about your inspirations and what you needed to do to come up with your design. You can make it short and sweet, but you need to have an artist statement. It needs to be there. And don't make it too long. The maximum is 200 words, okay? Do a word count. We don't like getting things which are too long. We have these limits for a reason. Don't explain your code line by line. If you're in doubt about anything for the assignment, please read the website. There will be lots of things to think about there. And now we're at question time. Gotten to the end of our today's lecture content. You may use a nickname, Shuai. Yes. I'm just going to hang out here for a minute. I might take a sip of water, then I might open VS Code again and hack something up. I've got an idea in mind for something, so we might try that. I'm glad that Yaya clarified Dr. Huang. You need a PhD for that first. I'm going to do my demo in a minute. Okay, so what do I want to do? First of all, I'm going to cut this code. I don't need any of that. Don't need that. Okay, we've got a black background. I'm thinking of making like a scene with some buildings or something. So I might draw some rectangles for buildings. While, or maybe I'll use a for loop, that would be better, I suppose. Number var number of buildings equals 10. I like to use variables in my loops because that means I can easily change them and I know what I mean when I write my code. If I just put numbers straight in, it can be difficult to work out what each number is referring to. But if I'm calling a variable number of buildings, it's fairly obvious what it's supposed to be. So for number of buildings, I suppose I don't want that. I want for var I equals 0, I less than number of buildings, and I equals I plus 1. Now you can take a little shortcut here. Here's a shortcut a few of you might have noticed. In lots of programming languages, I equals I plus 1 or something equals something plus 1 is so common that you get a shortcut to do it called plus plus. I plus plus is the same as typing I equals I plus 1. I think it's that way in JavaScript anyway. I guess we'll find out in a minute. Someone's just asked me a question. I've not been using var when defining a variable for the first time. Seems to work. I don't think that would work. Nope. Yaya has asked me if you have a long loop inside your draw function, the loop runs a separate process? Nope. Loop will block draw, and your frame rate will stop. Is a hopeful frame rate. Frame rate is a hopeful frame rate. Yeah, if you do too much stuff in your draw loop, then the frame rate will slow down in your function. So this may be not a good idea to do it in the draw loop. So I'm going to make a rectangle. I might make my fill color red. And I'm going to start my rectangle at an x value controlled by I. So I'm actually going to use the width of the frame to help me define this. I want to divide the frame into number of building size places to put my buildings. So x will be I times width divided by number of buildings. So the width of the frame is that far divided into the number of buildings, divided into 10 chunks. So 0 times that, I'll start at the left side. 1 times that, I'll start 1/10 of the way in, and so on until I get to the end. And my height of my building will be a random number. Maybe random like 200. That's not height, I need width to be... My y will be like height divided by 2. And then my width will be, I don't know, random 80. Okay. That's my rect. See how this goes. Oops, I got some problems here. Why didn't it work? Var number of building. I mean, it could be any number of things. Random that. I didn't put a comma in there. There you go. Here we go. Now I've got some buildings. Now I've got my first problem, which is that it's going to run over and over and over and over and over again. And I might change it so it just runs once. I'm not going to use the draw loop. I'll do it in setup. I get my buildings. Now, I've got a problem here, which is that my buildings are being drawn down, not being drawn up from the middle of the screen. I really want them to be drawn up. So I might need to change where I start, because I start drawing these rectangles from that top left corner. So I might work out at the start of my loop code, start my loop block, I need to do building width, maybe, equals random 80, and var building heights equals random 200, and then I'm going to change that one to building width, and this one to building height. Great, and then I can now change my starting point to be half the screen, height divided by 2, minus my building height. Okay, now I've got them going in the correct direction. And I guess I want to have like green grass or something below it. So maybe fill 0, 100. It's sort of nighttime or something, I guess. I'm just Bob Rossing this, making it up as I go along. It's your own little city and you can do it your own way or something. Rect is going to be a big rectangle covering the whole bottom half of the screen, if my hands are any way connected to it. 0, heights divided by 2. I'm going to make no stroke. And then there'll be width in width and heights divided by 2 in heights. Okay, I've got my green grass. That's too green. I want it less green than that, maybe 50. Okay, and each time I regenerate my code, I get different buildings because, you know, it's random. So I might change my random numbers here a little bit because I don't want my buildings to get too small. I might do it 200, random 200 plus 25. So they're at least 25 pixels high and then up to 225 pixels tall. And similarly for the height, the width, I might make them random 30 plus 60. So they're maximum 90, minimum 60, and they randomize in that envelope. So now I start to get my little cityscapes. So that's cool. I've got my number of buildings. What if I wanted to make like a number of rows of buildings, more than one row of buildings? So now I could do another loop to make buildings in front of buildings. So I might do another for loop with a different variable, j instead. J equals 0, I less than 3. I'm just going to hard code it now. J plus plus. So now I've got a loop within a loop. And all of my loop is going to be inside that, that other loop. Great. Let's see how that works. Whoops, I broke something. Oh, I less than 3. That should have been j less than 3. Whoops. It's very easy to make mistakes here. Now I've got some cool buildings. But I might want to offset them or something, or choose different numbers each time. Maybe different colors each time would be a good idea. So I've got my fill there. Fill, maybe it's going to be 50 plus j, 50 times j or something, 25 times j. And now as I get further towards the front, they get brighter. Oh, that looks cool now. So now I've got some very dim buildings in the background and brighter ones in the foreground. I could change a few other things just to start to move this a little bit. Maybe my X location should be like moved around a little bit. At the moment, they're all lining up on their left edge, but I want to, might want them to be a little bit more staggered. So I might subtract 10 there, minus 10 from that X location, plus random 20. So now the X location where I start my rectangle will be in the middle. The center will be there, but it could be a little bit to the left and it could be a little bit to the right. That looks cooler, doesn't it? Maybe even a bit more. Minus 15. And I might make their height higher. Trying to get some more variation in my buildings. That's starting to look like a really cool city. Another little thing, another detail could be maybe moving the whole line of buildings down the screen a little bit as we go. So the first one starts at exactly the horizon, or height minus height divided by 2. I might put this the start, actually. Whoops. Uh-oh. I go between my Mac laptop and my Linux desktop, and I always use the draw grass, draw night sky. I always use this the different keys on my keyboard for different stuff, so my hotkeys get changed up. And now draw rows of buildings. Doesn't look as good without the no stroke, or do you prefer it with the stroke? Stroke or no stroke, I'm not sure. I think I'll leave it as no stroke for now. That really has a kind of cool look. Maybe I'll make the stroke like a little bit darker than that. Yeah, just a bit of an outline. 15 times J. There we go, that's cool. Okay, now I've got to start my shifting of the line of buildings down. So the Y location was height divided by 2 minus building height. And then I'm going to add something related to J. That was my number of rows. Plus J times 10, maybe? Oh yeah, that's cool. Now I've got a cityscape. That's a little bit too much, maybe 8. Oh yeah. Got to get some like stars or something in the night sky. How about that? Draw stars. Do another for loop for var k. I could use I again for this one. It's this variable is outside the loop, the other loop that uses I. But I want to draw maybe 200 stars. Oops, k. And each star is going to be like just a point. That just draws one pixel, or maybe a very small ellipse. How about that? So that they twinkle a little bit. Ellipse. And it's going to start at random width, random heights divided by 2. So I'm just doing them in the sky, not on the ground. And that will be random. They should be both the same, shouldn't they be? The star size equals random 3. And I'll put that in here. Star size, star size. Uh-oh. That's got to be height, not high. Nope, still doing something wrong. What am I doing wrong? I hope that I'm apparently this reminds someone of Inception, the level 4 dream. So I hope you don't end up having infinite dreams where you're stuck in an infinite city loop. I needed to have a semicolon there, didn't I? Oh yeah, now I've got some stars. That looks pretty good actually. I'd like to have more stars. 600, see? Oh, that looks cool. Well, that's awesome. Sometimes I amaze even myself. I'm gonna make sure that I'm have the right kind of stroke. I think that they have, I'll need no stroke for that. And fill 255, so they should be white and there should be no stroke. Oh, so cool. That's nice. You can just wake up by having an infinite, forgetting a semicolon somewhere. Yeah, see, I think I got to my first point at which forgetting a semicolon really broke my code. Thanks, Shuai, that's awesome. I'm happy to hear that you like it. Yeah, I've got like half my screen is kind of full of nothing, so that's not that good. Maybe I should move the buildings down. I should add this to my intro video. I need a moon, maybe? Draw a moon. Draw a moon. I don't want it to be random, really. I want it to be in a random place, random width. Maybe the height should be like random 50 plus 100. I guess if the moon's like below the horizon, then it's not very impressive. So we should put it somewhere good. And I'm going to make it 100, 100. There's a moon. Can we take a chunk out of it? I guess it's a little bit tricky to get a chunk out of the moon, but and I want it in the right hand, the right half. Oh. Shouldn't be within two randoms. There's just one random required there. There we go. Okay, there's my cityscape demo. So I hope you liked it. Just a little bit of, I guess I didn't use any ifs, but a little bit of fun with iteration to chunk out of the moon. I know, but then Benedict, here was the idea from Benedict. Chunk out of moon, draw a slightly smaller circle in black. If I do that, if a star gets drawn in my little square out of the moon, that won't look very realistic. So I guess I was trying to think of a realistic way to do this, but like I need to draw a little weird ellipse shape. I'll think of it later. I'll publish this code on P5.js and send you the link. I always put my code I do in every lecture, these little experiments, into my shared list of sketches on p5js.org, so you can check them out. And maybe one of you folks will figure out a way to have the chunk taken out of the moon with me. So, yeah, okay. I'm going to call that the end of the lecture. Thank you very much for coming. Catch you next Wednesday.